Hey guys, Assalamu alaikum. I'm going to continue the lecture related to suppression techniques. I was dealing with the details about simple distillation in the previous lecture. We have discussed the details about this topic in which we have said that simple distillation is specifically used to separate a high melting point solid and a low boiling point liquid. Practical application of simple distillation is desalination, that is removal of salt from seawater to shift it into drinking water. Okay, today we are going to discuss a very important topic, and that is called as fractional distillation. Okay, guys, I would like to mention few details related to fractional distillation. Fractional distillation is different from simple distillation as it is containing an apparatus which is called a fractionating column. Okay. Number two is this, that fractional distillation is a detailed process. It is a more appropriate, more accurate apparatus. It is giving us a separation to a highest level. Okay. So here we can separate the two fractions which have very closed boiling points from each other, two or more than two fractions which have closer boiling points from each other. Before moving ahead, I would like to inform you that fractional distillation is based upon the physical property of boiling point. Melting point, boiling point, solubility, electrical conductivity, density, etc. are called as physical properties. So fractional distillation is based upon the physical property of boiling point. Okay. So depending upon the difference between the two or the three or more than three even, we can separate the fractions at their specific boiling points. All right. Before moving ahead, I would like to inform you that there are two very important industrial applications of fractional distillation regarding your syllabus as well. Number one is to separate the fractions of petroleum at their specific separate boiling points. All right. Some of the students are getting confused regarding the term petroleum. What is petroleum and what is the difference between petrol and petroleum? All right. So petrol is one of the component which is obtained by the fractional distillation of petroleum. Different fractions from petroleum will be obtained. I will teach you about different fractions one by one, inshallah, when that point will be there. But right now, I'm just telling you the different fractions of the petroleum are, for example, petrol, natural gas, diesel. You may consider different types of the polishes, waxes, etc., etc. Kerosene, for example, etc., are the components of petroleum, and they are separated at their specific boiling points. Okay, there is another industrial application is to separate the fractions, the components of air from each other. We already know this thing that air is a mixture of gases: 78% nitrogen, 21% oxygen, 0.03% carbon dioxide. Remaining gases are helium, neon, argon. Water vapors are present as well. If we are talking about dry gas, then definitely we will not discuss water vapors. Okay. So all these fractions of air can be separated from each other with the help of fractional distillation. All right. So fractional distillation is the basics for the separation of air components and for the separation of petroleum components. And I have told you that which is the physical property on which it is based. It is called boiling point. All right. Now, I am telling you very clearly here that we have taken the mixture in the mixture flask along with the anti-bumping granules. Anti-bumping granules can be glass bead, glass wool, or can be anti-bumping granules can be glass beads, or you may consider marble chips as well, not glass wool. Glass wool can be filled here. Let me talk about this later, but let me tell you about the anti-bumping granules. Anti-bumping granules, I'm repeating, can be either glass beads or marble chips. Okay. And the reason for using anti-bumping granules is discussed in the topic of simple distillation. Here I'm telling it again. For smooth boiling, we are using glass beads or marble chips. Okay. Now, we have this fractionating column inserted in the mixture flask. Done. What is the purpose of fractionating column? Fractionating column is used to separate the fractions at their specific boiling points. In one of the exam paper, examiner is asking what is the purpose, what is the use of fractionating column. It is used to separate the fractions at their specific boiling points. Okay, something is filled here in the fractionating column. What is that? Here I have pointed out very clearly, it is either glass beads or glass wool or marble chips. Okay. What is glass wool? This can create a confusion in your mind. Just consider cotton candy. It is made up of glass. Definitely, it is not made up of glass, but just giving you an explanation. So, just to these type of things are filled in the fractionating column. Why it is so? So that we may have more surface area for the fractionating column. Okay. So for example, if fractionating column is not filled, then what will happen? The fraction will move from here and it will move straight away up, okay? But right now, if these will be filled here, it will move left, right, left, right, left, right, top, bottom, left, right, top, bottom. And finally, a very pure fraction will be obtained and will move towards condenser. Just like simple distillation, there is a thermometer at the top of the fractionating column, and opposite to the thermometer bulb, there is an opening towards condenser. Now, before moving ahead, I would like to mention that there are two types of the bungs or the stopper which we have seen till now. One of the bung or a stopper is between fractionating column and the mixture flask. Remember this thing, sometimes examiner is making it open. As a result, what will happen, instead of moving the fractions toward the fractionating column, they will move away and they will move straight out of that flask. Okay, so there must be a bung or a stopper. Okay, then there must be a stopper or a bung with a thermometer as well. Otherwise, the thermometer will fall down in the fractionating column. Opposite to the bulb of the thermometer, there is an opening towards condenser. What is the condenser for? It is an apparatus which is used to shift the vapors of a substance back into the liquid state. Around the condenser, there is a water jacket. What is a water jacket? It is a jacket, it is a covering outside the condenser in which there is an anti-gravitational flow of cold water. Okay. Now there is again the same point which we have discussed in simple distillation. Why water is flowing? So that it may reduce the temperature of condenser. Hence, in this way, efficiency of the condenser can be improved. There is another question: why anti-gravitational flow of cold water? So that water may be in contact with condenser for a longer interval of time. Hence, efficiency of the condenser can be improved, or the maximum coldness of the cold water can be shifted to the condenser. All right. Now there is a receiver flask over there. I am just spotlighting. Okay, there is a receiver flask over there. There must not be a stopper. There must not be a bung in the receiver flask, so that the hotter fractions which are coming from the condenser may not develop the higher pressure. As a result, the flask will burst out. All right. Then there is an electrical heater over there. For which purpose, for which reason this electrical heater is used? Number one thing is this: sometimes the fractions are flammable. This is a very important point which I am telling you right now. Sometimes the fractions are flammable, they can catch fire. That's why we cannot heat this flask of mixture flask on the Bunsen burner. All right. Second reason why we are using electrical heater: for smooth and uniform heating. For example, if we are using electric heater, it will supply the heat on one side, on one place, specifically on the mixture flask, whereas the electric heater will supply uniformly in the whole available area of the mixture flask. Second thing was this. And what is the third point why we are using this electric heater? Is basically, in case of an electric heater, there is a thermostat. What is a thermostat? It is an instrument which is used for controlled heating. So for example, if I would like that temperature must not exceed 60 degrees Celsius, then I will adjust the thermostat on 60 degrees Celsius, and the temperature of electric heater will not exceed that. So due to all these reasons, a controlled heating, a uniform smooth heating, so that fractions may not catch fire, due to all these reasons, we are using this electric heater. All right, now I'm telling you one thing very clearly. For example, how we can implement this fractional distillation. All right, guys, just consider 5 fractions here. So for example, A, B, C and D are C, D and E are the fractions. This is boiling point 90 degrees Celsius. This is boiling point 93 degrees Celsius. This is boiling point 96 degrees Celsius. This is boiling point 100 degrees Celsius. And this is boiling point 105 degrees Celsius. All right. Okay. Now, what I'm telling you right now is this, that in this case, for example, at 90 degrees Celsius, what will happen at 89 degrees Celsius? Nothing will come out at 89 degrees Celsius when student will know that A is now coming out. At the temperature of 90 at the thermometer, the receiver flask will start receiving fraction A. All right. The next question which examiner is usually asking is this: how student will get to know that all fraction A is removed? When temperature on thermometer will be more than 90 degrees Celsius, it will give us an indication that all A is removed. Okay. So when what will start coming at 91? Nothing. At 92, nothing. At 93, B will start coming. So we will remove that flask, that receiver flask for A, and we will keep another flask for B, a new flask for B. At 93, B will start coming. When the temperature will be more than 93, it will give us an assurance that all B fraction is removed. Then at 96 exactly, C will start coming. When 96 will be over, C will be finished. At 97, 98, 99, nothing will come out. At 100 degrees Celsius exactly, D will be coming out of the condenser, and then 101, 102, 103, 104, nothing will start coming out. And at 105, we will be left with D only in the mixture flask. All right. So in this way, we can have an assurance for the perfect separation. In this way, we can have a clear separation for all of these. And this is the technique to separate those fractions which have very close boiling point. Guys, there is one more example which I am going to tell you, and that is related to oil, not oil, this is related to ethanol. Yes, we can take this example: ethanol and water. All right, guys, ethanol is an alcohol. It is one type of alcohol. There are many types of alcohol. I will teach you different types of the alcohols one by one, inshallah. But right now, ethanol has a boiling point of 78 Celsius. All right, boiling point of 78 Celsius, whereas water has a boiling point of 100 Celsius. Okay, so the point is this, that these two fractions have a very close boiling points from each other. So how we can separate the two? And remember this thing, that ethanol and water are 100% soluble, 100% miscible into each other in all the proportions. But how we can separate the two? With the help of fractional distillation. Is that okay? This is the only way to separate the two. As they are 100% soluble into each other, we cannot use the method of solvent extraction. Solvent extraction is the method which I have discussed with you in the previous video, in which I have told you that solvent extraction can be used to separate the two liquids which are not soluble into each other. Okay, so ethanol and water can be separated from each other with the help of fractional distillation. Okay, thank you very much, guys. See you all in the next class, inshallah. May you all rise and shine in chemistry due to this channel. Thank you very much. Take care. Allah Hafiz.